A little over a year ago, I interviewed every engineering discipline in my university to kind of get a better sense of what all of the engineering disciplines actually do. What do all these programs actually do? And even currently in my 5th year of mechanical engineering, I honestly was very surprised about some of their answers, and I was like, what? Wait, you actually do that? Bro, you actually do? So yeah, there were basically a lot of things in that video that surprised me and I found were really valuable to share to students. Today, I'm gonna be going over a more condensed version of that video, basically. And I'm gonna be going over what I learned throughout all of the interviews. If you're interested in checking out the entire video, it's like a 2-hour video. Check the link right here. You can click up here. But anyways, let's get right into this thing. First up, we've got my favorite, mechanical engineering. And in this interview, we first started off talking about how mechanical engineering is basically the broadest discipline. And maybe I'm a little bit biased in saying that, but seriously, it's one of the broadest disciplines that you can possibly take in engineering. And it's really because of what you'll learn in mechanical engineering that actually makes it that way. We actually really study almost all of the disciplines. And having this variety of skills and interdisciplinary knowledge actually makes you really well suited for stuff like managerial roles in companies, and actually just makes you very versatile in your career. In my interview with Brandon, we also talked about some of the biggest reasons why students actually join the program. And one of the biggest reasons why people actually join the program is because of how broad it is. That's basically why I chose it in the first place as well, but also because of how tangible those results actually are. One of my favorite things about mechanical engineering and what mechanical engineering encompasses as a whole is that you can directly see what you're making and see it actually work. Sorry, civil engineers, I know you can't actually do that because your stuff is not moving. Your stuff doesn't move. I'm sorry. I don't want my building to move. I'm sorry. And then we talked about what is the difference between co-op and the traditional route, and kind of talking about the pros and cons between each of them. If you don't know already, the traditional route is just the regular 4-year route of engineering, where you're basically just going to study throughout the entire time and then have those breaks in between. But with the co-op, the better program, that's when you actually extend your degree to 5 years, and then you'll be able to have those co-op work terms, those engineering co-op work terms in between your study terms. So you're getting that study, that knowledge experience, that academic experience that you're gonna get regardless of the program that you're in, but you're also going to be getting paid work experience. And then we kind of talked about some of our personal experiences. From my experience in mechanical engineering, my co-ops so far were one in civil engineering. I know it's weird, but yes, that is how it kind of worked out. Then my second one was in project management. And this kind of hints at the broadness of mechanical engineering, especially with project management. In terms of the courses that were taken, we take stuff like kinematics, kinetics, heat transfer, fluid dynamics, basically anything that moves that you can hold or not hold, whether it's a fluid, whether it's a solid, anything that moves is in the scope of mechanical engineering. And we also have to take into consideration when stuff doesn't move, which is the civil engineering part of mechanical engineering that unfortunately we have to take. Dang it. And then in the interview, we actually talked a little bit about extracurricular activities that we took in our engineering programs. And one of them being our club experience in Alberta SAB, which is a satellite design team essentially. So yes, there are a lot of cool things that you can do with a mechanical engineering degree. Club experience is really easy to get into because so many clubs can use mechanical engineering students. Now I will mention that one of the things that we did mention in the interview was that one of the biggest misconceptions about mechanical engineering is that you need to be mechanically inclined in order to get into mechanical engineering and to succeed into it. That's not entirely true, and the reason is this. Some mechanical engineering students have never touched a screwdriver in their entire life, and that's just the reality of it. It might be mind-blowing at first, but that's just the reality of it. This hints at the broadness of mechanical engineering. You don't necessarily go into mechanical engineering just because you build cars on your weekends or you like to design robots whenever you have free time. that's not necessarily what a mechanical engineering student is. A mechanical engineering student is someone that has that broadness and that capability to learn about all different various disciplines and to apply them into managerial roles or technically. Now, let's get into the next one, being electrical engineering. And we first talked about the diverse branches of electrical engineering with telecommunications, power and systems, electronics, and that electrical engineering does have a reputation to be one of the hardest disciplines, if not the hardest discipline. I guess maybe one of the reasons is because you guys use imaginary numbers, electrical engineers. Guys are weirdos. Why do you use imaginary numbers? So yeah, it's really because of these vast number of industries that you can join as electrical engineering students, which is one of the biggest reasons why electrical engineering students go into that program, because of the variety of industries. And we talked about how easy it is to become a hobbyist in electrical engineering. A lot of people in electrical engineering are hobbyists, and you know, they create their own circuits or whatever it is. So yeah, that's one of the reasons why people join. And then next we talked about some of the courses that electrical engineering students take, which we mentioned was circuit theory, digital design, power engineering, control systems, and embedded systems, just to name a few. So as an electrical engineering student, you're learning the foundational skills and knowledge that you need, and then that advanced knowledge as well, obviously.
Fourth year is where really the gates are open, basically like a choose your own adventure game kind of. So people will take stuff in like microwave electronics. It's where you get all the weird names coming in. Yeah, photonics introductory to nanofabrication, telecommunication, and signal design.
In terms of co-op experience, this student was able to engage in working with control systems, panel designs. Luckier than me, was able to get into something related to their discipline in their co-ops. Yeah. And then we talked about some of the personality traits for success in electrical engineering, where it was mentioned that curiosity and the ability to experiment with hardware is essential. So having that hobbyist mentality is really valuable in electrical engineering. Next up was my conversation with the computer engineering student, Anushka. Here we talked about how computer engineering is more the integration of the hardware and software together.
I think it's a beautiful mixture of electrical and software where we get the best of both worlds.
And she kind of talked about some of the versatility of this discipline in the tech industry. As for some of the reasons why people join computer engineering, students were interested in technology and coding, along with a desire to develop tangible solutions. For some of the core courses that are taught in computer engineering, these include digital systems, microprocessors, circuit design, and software development as some of the big ones. In terms of her co-op experience, she was able to work at Microsoft and BlackBerry, which was pretty interesting to hear about actually. And she kind of just talked about her internships in cybersecurity and cloud architecture. And then I kind of asked her, what are the differences between computer engineering and software engineering? Here she kind of mentioned more how computer engineers focus more on the hardware aspect of things, while software engineers emphasize more on software development, obviously. However, both fields have their overlaps and job opportunities. And she did mention this.
But also as a compie, I'll say, as a compie, I can take a software job, but a software can't take my job.
Next up, we have chemical engineering. Right off the bat, I had to emphasize the biggest misconception about chemical engineering, which is that chemical engineering isn't as chemistry focused as you would expect from the name. Here, Nikhil was able to clarify about this misconception, talking about how it doesn't solely focus on chemistry, but instead it highlighted more about processes and reactors and how these chemical factories, how to scale these chemical processes, kind of.
Chemical engineering really, in my opinion, should be renamed to process engineering, because that's really what we do. An example I give people is you have a coffee machine. So the entire process from getting, your beans, your coffee beans, to an espresso that you drink, designing that entire process is what chemical engineers do.
Students that did join chemical engineering were usually students that were interested in various industries, including pharmaceuticals, energy, environmental sectors, and even stuff like makeup was mentioned too, which was pretty interesting. In terms of courses, some of the key courses were reactor design, thermodynamics, fluid dynamics, heat transfer, numerical methods, just to name a few. Students also learned to design chemical processes and understand reaction kinetics. Next up was an interesting one, because now we have materials engineering, where I got to talk to a PhD student. Yeah, PhD. Damn. where here we talked about how materials engineering focuses on the material properties, processing, and performance in various applications. The reasons why students actually join this discipline is because they were interested in stuff like applications of technology, in electronics, aerospace, all different kinds of things. Basically, how do we take this rock and make it useful? Like, make it actually useful in our design. Materials engineering in a nutshell. In terms of courses that are taught, materials engineering students learn about phase transformations, material characterization, corrosion, and materials processing, just to name a few. Basically, students learn how do you manipulate materials to get their properties, to get desired properties. And then we talked about Daniel's experience with the CCWJ, the welding research team at the University of Alberta, and how that was really a core factor into him getting his PhD and his whole experience.
It's a doctor of philosophy. So you are at the cutting edge, the highest level of thinking possible for that discipline. One key aspect of a PhD is anything that you do has to be novel. It has to be new. I focus on welding and understanding the material processes and the process of welding behind it. There's a lot of power with understanding, and industry pays for it. You just have to find the right spot for it.
In terms of career opportunities, materials engineering has a ton of industries that they can work with, including aerospace, automotive, electronics, biomedical. I mean, things need to be made out of something, right? So need to know what material to use. Next up is mining engineering, where first we talked about the diversity in skill set that you actually learn in the discipline. And we also mentioned how these skills can actually help you develop further than just mining operations alone. Students that joined mining engineering were really attracted to the discipline because of it just sounds like Minecraft. They liked extracting resources. It's literally Minecraft. It's literally Minecraft. Students that were interested in this discipline were interested in, yes, the extraction of resources. Mining. And we also mentioned how sustainability was a big part of that as well. For courses, mining engineering covered stuff like geotechnical engineering, mine design, mineral processing, just to name a few. For this student's co-op experiences, he talked about his various placements and how he had a lot of on-site work, especially at mines, and how he was making that. He was really making.
You'll make over 6 figures in your first job easy. Most people make at least 120.
In terms of the personalities that actually join mining engineering, talked about how ideal candidates really enjoy outdoor work and are willing to adapt to these different environments that you're going to be experiencing. Next up, civil engineering. Okay, fine. I'll talk about civil engineering, fine. This conversation with our civil engineering student was basically just talking about the importance of civil engineering in constructing infrastructure. Yes, in constructing infrastructure and designing it as well. And people that join the discipline are obviously people that are interested in building stuff like bridges, roads, buildings, stuff that are large scale and don't move. They don't move. And they're big. Yeah. In terms of courses, we talked about how it includes structural analysis, transportation engineering, water resources, and project management courses. In terms of that co-op experience that she had,
for my first 8 months, I had like 60% office exposure or technical work, and then 40% field work. Technical wise, I was able to like analyze data such as like rainfall data, land movement. I did traffic counts during rush hour within the city.
And then we talked about what is the difference between architecture and civil engineering, where architecture is basically more focused on the aesthetics of the building, whereas civil engineering actually needs to take into the consideration of, is this thing actually possible with our physics models and what we know of the real world. So actually checking for feasibility, safety, and functionality. But next up, we have environmental engineering, which is technically a subdiscipline of civil engineering. And here it is emphasized that the discipline is not solely about environmental construction. Environmental engineering is actually much different than sustainability engineering, which is one of the biggest misconceptions about this discipline. But yes, the people that actually do join this discipline are passionate about the the environment and how they can actually engineer the environment.
Literally engineering of the environment. So we're like using environmental processes and manipulating them to a certain goal.
The co-op experience that we talked about from this interview was one of the most interesting co-op experiences that I have heard about, where we talked about the placement in consulting firms and working with indigenous communities to provide environmental science training, which is talked about more here.
My second co-op term, I worked for an NGO, a nonprofit. I was working in sometimes very remote indigenous communities, leading community workshops on how to do even like catching fish. I had to learn how to like dissect fish.
In terms of those career opportunities, however, graduates can work in various fields, including environmental consulting, wastewater, water resources, just to name a few. We also talked about how the demand for environmental engineers is expected to grow with that increasing awareness of environmental issues. But now we talk about one of the smaller disciplines, which is engineering physics, and how engineering physics is exactly how it sounds like: engineering and physics put together. And here we talked about how engineering physics focuses on developing technology and innovative solutions with that combination of engineering and physics. Literally, they're literally put together, yes. And one of the biggest reasons that we talked about why students actually join engineering physics is because of their passion in theoretical physics, and then taking that theory and applying it through engineering. That's the whole point of this discipline, basically, yeah. The courses in this discipline include quantum mechanics, electromagnetism, modern physics, basically just emphasizing both the real-world application part of it and the theoretical part of it.
For me, a lot of engineering physics is actually electrical engineering. Like, we take a lot of the same courses. It starts off basic engineering, a lot of electrical engineering, and then as you get higher and higher, you start moving away from electrical engineering into theoretical physics is what you're learning mostly by the end of it.
Our student Keaton was able to share his experience in research positions, including working in microfabrication and developing micro electromechanical systems. What does that mean? And in terms of career opportunities, we talked about how graduates can work in diverse fields.
I feel as though with a little bit of extra elbow grease, I could go into any industry I wanted to. Like, we learn the fundamentals, I think, at least, for electrical engineering, mechanical engineering, chemical engineering, computer engineering. I feel like those 4 pillars, we could branch out into any one of those if we really tried to. Electrical engineering is definitely the most suitable because we learn tons of electrical engineering courses, but we also get enough that if we pushed ourselves further, we could branch out into really anything you wanted.
Next up, we have petroleum engineering, where we talked about some of the biggest misconceptions about petroleum engineering, which was that petroleum engineering is limited to just oil and gas, which was not necessarily true, but more highlighting its relevance to renewable energy and sustainability. The main theme of this interview was that students that join this discipline really want to work in energy sectors as a whole, other than just focusing on petroleum. Some of the courses that students learn are drilling engineering, production and reservoir engineering, geology, and economics behind oil and gas evaluation. We also talked about the co-op experience as the relief operator, conducting oil sample tests and evaluating water cuts to determine well viability. There was an emphasis on that hands-on field work throughout this interview, I would say. In terms of those career opportunities in petroleum, it was really nice to hear that it actually wasn't just limited to oil and gas, but instead it does have that upstream and midstream relevance to it, but other things such as renewable energy, such as hydrogen energy and carbon capture technologies was a part of it. And then next up we have software engineering, where I was able to interview my boy Jared and talk about how software engineering as a field focuses on problem solving through programming and software development. That was the encompassing theme in this interview. And it comes to no surprise that some of the reasons why people join software engineering is because of their interests in technology, coding, and creating solutions for those real-world problems using software. In terms of the courses that are learned in the discipline, we went over software design, development, system architecture, with some exposure to hardware aspects as well. But I think out of all of the disciplines, one of the biggest takeaways from software especially were the extracurricular activities that were done outside of school, and how important that is, especially in the software space. So participating in stuff like clubs, hackathons, making your own personal projects were all things that were talked about and seemed valuable in software engineering. In terms of Jared's co-op experience, we talked about his experience working at startups, emphasizing the fast-paced environment where students can directly impact software development and client interactions, and what it's like being in that smaller type of company. And then we talked about the most important question, which is what is the difference between software engineering and comp-sci? Computer science. Here, Jared kind of highlighted that software engineering includes a more structured approach with a focus on software reliability, design principles, and kind of a little bit of engineering practices because you have that engineering background. While computer science may emphasize theory and algorithm foundations, but they really are truly competing in very similar markets at the end of the day. Last but certainly not least was probably the most interesting conversation out of the bunch, which was with biomedical engineering. Here I was able to talk with biomedical engineering student Connor, who is actually the founder of Wound Cubed, which I will talk a little bit more later in the video. But first we talked about how biomedical engineering is the integration of biology and engineering principles to develop these medical technologies and improve healthcare solutions. Also, it's good to note that biomedical engineering is actually a subdiscipline of mechanical engineering. So there's naturally going to be a lot of overlap between the two disciplines. But in terms of the course difference between mechanical engineering and biomedical engineering, the courses that are taken in biomedical engineering include anatomy, physiology, medical imaging, blending engineering principles with that medical knowledge. That's kind of like the whole theme of biomedical engineering. How do we take biology and mechanical engineering, put them together? Now, this interview with Connor was really special because we were able to talk a little bit about his extracurricular activity, which is an incredible extracurricular activity, founding Wound Cube, which is essentially an app that is able to render wounds and basically study wounds in a three-dimensional manner, basically providing a solution to the very much outdated way of measuring and evaluating wounds in today's healthcare system. That's essentially the problem that he was going after.
What we do is we build software that basically allows patients or clinicians to download what's called Wound Cubed onto their just iPhone or iPad.
Whoa.
Sort of renders wounds in 3D. It sort of analyzes the growth patterns of that wound over time and has a lot of data visualization features.
I was blown away by this interview, not gonna lie. In terms of career opportunities for biomedical engineers, graduates can work in diverse fields again, but with an emphasis on stuff like medical device development, healthcare technology, research, and clinical applications, which I will mention now is a big part of biomedical engineering. And the difference between their co-op and mechanical engineering co-op is that there are clinical experiences tied within the biomedical field, whereas mechanical is really just engineering co-op experience. So that's one of the biggest differences, especially in the co-op experience between the two. So I went over a ton in this video and really tried to condense all of that information in that 2-hour period. But if you really want to check out the entire interview process and all of those interviews, check out this video right here, which is the link to that video. There are timestamps throughout the video so you can check each of the disciplines. But anyways, thank you guys so much for watching, and I'll see you guys in the next one. Press that like, hit that subscribe, and leave those comments. Peace. Peace. Peace, guys. How's the setup? How'd the setup going? Y'all like looking down. Y'all like looking down at me. It's like you're the authority. Like, yo, step up. Step up. Step up.